Hello everyone. In this video we are going to discuss about chemical engineering GATE 2020 chemical reaction engineering questions with solution. GATE 2020 question paper and the answer key link is available in my description box. You can download it. Question number 44. An elementary liquid phase reversible reaction P gives Q is carried out in an ideal continuous stirred tank reactor CSTR operated at steady state. The rate of consumption of P minus RP is given by minus Rp is equal to Cp minus 0.5 Cq. Rp unit mole per liter minute. Where Cp and Cq are the concentration of P and Q. Concentration unit mole per liter respectively. The feed contains only the reactant P at a concentration of 1 mole per liter. So meaning of this, Cp naught is equal to 1 mole per liter. What about the Cq naught? Cq naught we should take 0. Why? Because the feed contains only the reactant P. And the conversion of P at the exit of the CSTR is 75% of the equilibrium conversion. Meaning of this conversion mean that is XP. XP is equal to 75% means 0.75. So 0.75 times of equilibrium conversion. Equilibrium conversion means that is XP. E represent the equilibrium. Assume that there is no volume change associated with the reaction and the temperature of the reaction mixture is constant throughout the operation, that is constant temperature or isothermal condition. The space time of the CSTR is objective of this problem is to determine the space time. Space time is designated as tau. Tau in minute. Tau of the what? CSTR or MF1. After calculating the space time in minute, so space time value we have to round up the result to 1 decimal place. Okay, so after calculating the space-time value, we have to round off the result to 1 decimal place. Yeah, so here data. So data P gives Q. This is given equation. This is the liquid phase reversible reaction. So here what is the K1? K1 is a forward reaction rate constant. K2 is a backward reaction rate constant. P is the reactant. Q is the product. Reaction is a reversible reaction. So rate of the reaction minus Rp is equal to Cp minus 0.5 times of Cq. So meaning of this, K1 into Cp minus K2 into Cq. So from this, what is the K1? From this rate of reaction, K1 is equal to 1. So 1 into Cp na. So here this is 1. So what about the K2 here? K2 is equal to 0.5. So from this reaction. So what about the Cp naught? Cp naught here 1 mole per liter. Why? Because feed contains only the reactant P. So what about the CQ naught? CQ naught value we should take 0. So here feed contains only the reactant P. So then conversion is equal to 75% of equilibrium conversion. So XA is equal to 0.75 times of XAE. So our reaction we should write XP is equal to 0.75 times of XPE. Okay. So this is the our problem. So we have the reactant P is right. XP is equal to 0.75 times of XPE. No volume change. Temperature is constant. So these are the condition is given. Based upon these data, we are going to calculate the space-time value. Okay. So objective of this question to determine the space-time of CSTR. Space-time is designated as tau in minute. Okay. So solution part. This is liquid phase reversible reaction. So this is our reaction. Am I correct? P gives Q. So the K1 is a forward reaction rate constant. K2 is a backward reaction rate constant. So here what is a Kc? Kc is a equilibrium constant. So the equilibrium constant is defined the ratio between forward reaction rate constant to backward reaction rate constant. So the Kc is equal to Kf by Kb. So the Kf is a forward reaction rate constant. Kb is a backward reaction rate constant. So the forward reaction rate constant as per our reaction, that is K1. So backward reaction rate constant is a K2. So the K1 by K2 is equal to, so from the equation minus Rp is equal to Cp minus 0.5 Cq na. So here what is a K1? K1 is a 1. So what is a K2 here? 0.5. So the K1 by K2 is equal to 1 by 0.5, that is equal to 2. So this is the equilibrium constant. So the Kc value 2. At equilibrium condition, Kc is equal to Cq by Cp. Cq is the final concentration of Q. Cp is the final concentration of P. That is equal to m plus XAE by 1 minus XAE. So here m is the molar ratio, XAE is the equilibrium conversion. So here m is equal to Cq naught divided by Cp naught. So what is Cq naught here? Cq naught is equal to 0. Cp naught values are given. Okay. So take this expression. Kc is equal to Cq by Cp is equal to m plus XAE by 1 minus XAE. So from that, what is a Kc? Kc is a calculated value 2, that is equal to Cq by Cp. So then take this two equation. So the Kc is equal to m plus XAE by 1 minus XAE. We want XAE value. XAE mean our equation, that is called as a XPE. Okay, both are equal. Okay, so generally it is represented as capital A. So as per the problem, we should take the reactant is a P. Okay, so XAE and XPE both are equal. So here m plus XAE by 1 minus XAE. So here what is the m value? M is a Cq naught divided by Cp naught plus XAE divided by 1 minus XAE. So Kc values are 2 na. So here this is rearranged in this expression, numerator part. So what is this value? So Cq naught plus XAE is Cp naught. Okay, whole divided by Cp naught into 1 minus XAE na. So here Cq naught equal to 0. Why? The feed contains only the reactant P. So we should take Cq naught value is equal to 0. So don't consider the Cq naught. Only take the Cp naught. So the numerator part Cp naught into XAE whole divided by Cp naught into 1 minus XAE. So here Cp naughts are cancelled. Finally we get XAE divided by 1 minus XAE is equal to 2. So rearrange this expression. So 2 minus 2 into XAE, that is equal to XAE. So here 2 in left hand side, right hand side the XAE plus 2 XAE, that is equal to 3 XAE. So finally we get XA is equal to 2 by 3. This XAE equal to XBE, both are equal, okay. So here generally what is the condition is given in our problem. So XA or XB is equal to 0.75 times of XPE, okay. So this is condition is given. So once you know the XPE value, substitute here, find out the conversion value. So this is written as XA is equal to 0. General equation 0.75 times of XAE, that is equilibrium conversion, XAE, okay. So here we know the XAE value na. XAE value, what is this? XAE is a 2 by 3. So substitute here 0.75 into XAE na, 0.75 into 2 by 3. What is the equilibrium conversion here? 0.5. So this XA is equal to XB. Our equation, the reactant is a P. Generally we should write XA. So this XA is equal to XP for our equation. So this is the conversion value, final conversion, that is 0.5. Okay. So now we have the XA or XP value. So our objective to determine the space time of the CSTR. Okay. So for CSTR, so what is the space time equation? So tau is equal to Ca naught minus Ca by minus RA. So our reaction is a P gives Q na, already I said the general equation Ca naught minus Ca by minus RA. Our equation P gives Q mean, so our reactant is a P. So this equation can be written as Cp naught minus Cp divided by minus Rp. Am I correct? So here tau is equal to Cp naught minus Cp by, what is the minus Rp? Minus Rp is given in our problem. We should write Cp minus 0.5 Cq. So substitute here. So what is the Cp and the Cq value here? So the Cp naught into 1 minus Xa, Cq Cp naught into m plus Xa. Okay, generally what is the m? M is the molar ratio, Cq naught divided by Cp naught. So from this, what is the Cq naught? Cq naught we should take 0. So the Cp naught only given in our problem. So why is Cq naught equal to 0? In problem itself they have mentioned. So if it contains only the reactant P, we should take Cq naught is equal to 0. Okay. So here after substituting this value Cp and Cq, what is the tau equation here? Tau is equal to, so numerator part Cp naught minus Cp whole divided by, what is the denominator term? Cp. Cp is equal to Cp naught into 1 minus Xa minus 0.5 into, what is the Cq here? Cp naught into m plus Xa. So the numerator part you don't worry, the same term Cp naught minus Cp whole divided by denominator term Cp naught into 1 minus Xa minus 0.5 into here Cp naught into m plus Xa na. So Cp naught into, what is the m value? Cq naught by Cp naught plus Xa. Okay. Yeah. Then rearrange this expression. Tau is equal to numerator part Cp naught minus Cp means Cp naught into 1 minus Xa. You see in numerator part here. Yeah. Cp naught minus Cp na. What is the Cp here? The Cp is a Cp naught into 1 minus Xa. So here Cp naught into 1 minus Xa. Am I correct? So this is the numerator term. Denominator Cp naught into 1 minus Xa minus 0.5 into Cq naught plus Cp naught into Xa. How it is come this value from the previous one? Check here. Yeah. So here 0.5 into Cp naught into Cq naught by Cp naught na. Here multiply with Cp naught. Cp naught are cancelled, the first term. Second term Cp naught into Xa. Final term 0.5 into Cq naught plus Cp naught into Xa. That term here. Okay. So check this expression. So finally we have Cp naught is a 1 mole per liter. Substitute here. Xa values are calculated value 0.5. So substitute. Then Cp naught, already I said 1 mole per liter given data. So Xa is 0.5. Here minus 0.5 into Cq naught, already I said 0. Don't worry about the Cq naught. Plus 1 into 0.5. Finally we get tau values are 2 minutes. Okay. So answer for this question, tau is equal to 2 minutes. Okay, so answer range is given. So answer range for this problem is tau values are 1.9 to 2.1. Okay, so this is answer range. So our answer within this range, our answer tau of CSTR is equal to 2 minutes. So here range is a 1.9 to 2.1. Our answer within this range. Okay, so for further related videos you can like, share and subscribe my channel. Thank you.